In this lesson, we are going to use double angle identities to find exact values of trig functions. This will require us to create and use reference triangles. And so remember, we're usually given information about two sides of the triangle, and we also know enough as to where the triangle is located, and so we can sketch that triangle, and then we'll use our Pythagorean theorem to find the third side, and then we'll be ready to find the exact values. So double angle identities, here we go. We only have one for sine and one for tangent, and then there are three for cosine. There's a reason for that, and I'll tell you which one it's probably best to use for these problems. But if you are asked to find the exact value of sine of 2 alpha, breaks down like this. So alpha is the one angle that you're working with in these problems. And notice the formula says 2 times sine of alpha times cosine of alpha. Because I don't know if you would know what to do with sine of 2 alpha, so we break it down into a simple formula, 2 sine alpha cosine alpha. So if you know the value of sine, if you know the value of cosine, you can multiply those together, times it by 2, and that's the value of sine of 2 alpha. But you'll see what I mean when we look at an example. Tangent of 2 alpha involves us calculating 2 times tangent of that angle, and then dividing by 1 minus tangent squared of that angle. Now, cosine of 2 alpha has 3 different variations. And if we had the opportunity to actually work more with trig identities, you would understand why there's 3 of them, and that all 3 of them are equivalent. Like they're each, no matter which one you use, you're going to get the same answer regardless. However, with these particular problems, when you are finding exact values, I would use this first formula because I think it's the most user-friendly one to use when you're finding exact values. And so if I want to calculate cosine of 2 times an angle, I want to calculate cosine squared of that angle and sine squared of that angle. And then I'll subtract these two values. So let's take a look at exactly what I'm talking about. So first we draw a reference triangle for alpha. In this problem, we're given that sine of alpha is 12 over 13, and that alpha is located between 90 and 180. So alpha is in quadrant 2. And so I'm going to draw a reference triangle for sine in for this problem in quadrant 2. And so here you can see that I've done that. Sine is the opposite over the hypotenuse, and then I used Pythagorean theorem to find the missing side. And remember, watch your signs. I mean positive versus negative, because in quadrant 2, x values would be negative. So make sure you're checking for that before you actually go finding your exact values. You can already see on the right side of the screen that I've already found sine of 2 alpha. So remember, the formula for sine of a double angle was 2 sine alpha cosine alpha. That's how it broke down. Okay, and so I'm going to use the breakdown when I'm like trying to figure out what is sine of the double angle. And so the formula says 2 times sine of alpha cosine alpha. So I use my reference triangle and I figure out what is sine of alpha. And sine of alpha is 12 over 13. And then I use the same reference triangle and I'm like, what is cosine of alpha? Cosine of alpha is negative 5 over 13. And once I've substituted these trig values into my formula, I can then do the multiplication. So 2 times 12 times negative 5 is negative 120, and 13 times 13 is 169. So I'm using the formula and I'm making the substitution of all those trig values in the formula to determine what this is. So notice, like, I didn't substitute anything into sine of 2 alpha because I don't know what the double angle is, but I know what alpha is. And so I have to use the formula, the identity, what it's equivalent to in order to figure out what that exact value is. In problem 2, I'm working with cosine of 2 alpha. So once again, I wrote out my formula. My formula is cosine squared alpha minus sine squared alpha. And so basically, when I calculate cosine squared alpha, I need to be like, well, what's cosine alpha? Cosine's the adjacent over the hypotenuse. So it's negative 5 over 13. And then I can square it. And when you square a ratio like this, you square what's on top. So negative 5 squared is 25. And then you square what's on the bottom. 13 squared is 169. Going back to the formula, it says minus sine squared alpha. So I go to my reference triangle. I'm like, what is sine? Sine is 12 over 13. Then I square that. 12 squared is 144. 13 squared is 169. And then I can finally subtract these two fractions. And I get negative 119 over 169. So use the reference triangle to find the exact values of the trig functions in the formula. Substitute those values in, simplify to get your final answer. In problem 3, I want tangent of 2 alpha. And this is the formula I have it in green. And it's 2 times tangent of alpha divided by 1 minus tangent squared alpha. So I go to my reference triangle and I'm like, what's tangent of alpha? And tangent is the opposite over the adjacent. So in my numerator, I have 2 times tangent alpha, which is negative 12 fifths, divided by 1 minus tangent squared alpha. So I've got my tangent of 12 over negative 5, and I'm going to square it. So notice in the next step in purple, I've done that. So in the numerator, I multiplied this together. So 2 times negative 12 fifths is negative 24 over 5. And then on the bottom, I have 1 minus, and then this 12 over negative 5 squared is 144 over 25. This is a complex fraction because I have a fraction within a fraction. And in order to get rid of that, I need to multiply all 3 terms by the common denominator. And the common denominator is the bigger one, the 25. And so notice that I'm multiplying all 3 of those terms by 25. Okay. And then I'm simplifying the result here. So up on top, when I multiplied negative 24 over 5 times 25, what happened is those two kind of canceled out. I was still left with 5 on top. And then negative 24 times 5, that's how I got, I guess, initially negative 120. So I'll just write it down here, negative 120. And then on the bottom, I have my 25 times 1, and that's easy enough. Minus, and then here, when you go 144 over 25 times 25, those 25s cancel out completely. And so I just have minus 144 on the bottom. And so then when I actually did the subtraction on the bottom, I had negative 120 over negative 119, and a negative over a negative is a positive. And so this is my final answer. But my double angle formulas, I'm simply using my reference triangle and I'm getting the exact values of the trig functions in my formulas, and I'm substituting those values in, and then I'm simplifying to get the result. So why don't you give a few of these a try on your Google form, and then check back in with me. There's one type of problem I'd like to go over with you still.